How is it possible that a failed star, which does not produce light, can still emit luminous signals? The James Webb Telescope has unveiled this mystery by detecting an infrared light that is barely visible in our world, without the aid of advanced technology. However, in another dimension, this dark star could appear as a shining sun. Brown dwarfs are enigmatic objects in the cosmos, also known as failed stars, because they share some characteristics with stars but lack the necessary mass to initiate the hydrogen to helium nuclear fusion process, which is essential for producing light and heat. These celestial bodies form from the collapse of gas and dust clouds, similar to stars, but they do not shine like conventional suns. Brown dwarfs have many physical properties in common with stars, such as a spherical shape and an initially hot surface. However, with a mass between 13 and 80 times that of Jupiter, they cannot generate the pressure and temperature in the core necessary to start hydrogen fusion. In the early stages of their development, they can fuse deuterium, a heavy isotope of hydrogen, but the deuterium reserves are quickly exhausted, limiting this process to a brief period. Unlike stars that enter the main sequence and shine steadily for billions of years, brown dwarfs cool over time, becoming increasingly faint. However, despite their seemingly dark nature, they emit a mysterious infrared glow that the James Webb Telescope is capable of detecting. James Webb captures infrared signals and analyzes them with 4 specialized spectrometers, revealing the mysterious glow of brown dwarfs. These celestial bodies occupy an intermediate position in the universe, between the largest gas planets and the smallest stars. Scientists are beginning to consider brown dwarfs as a separate category, with unique characteristics yet to be explored. One of the most surprising discoveries made by James Webb concerns the aurora around the brown dwarf V1935, located over 40 light-years from Earth. This brown dwarf is bright and close to other stars, an unusual situation for these objects, which usually appear isolated. Initially, it was thought that V1935 might reflect the light of the surrounding stars, but the telescope detected methane emissions, suggesting that the aurora might be caused by atmospheric heating due to charged particles. Another theory proposes that interstellar plasma colliding with V1935 could trigger the aurora. Although interstellar plasma is less dense than the particles emitted by stars, it could still explain the mysterious infrared glow. It is possible that the brown dwarf receives particles from an active moon or another nearby celestial body, a hypothesis that James Webb could help verify. Although brown dwarfs are common in space, they have often been considered failed stars. However, we may have overlooked the fact that they shine in another class of light, belonging to a world of dark objects that we are only now beginning to see and study thanks to James Webb. There is a dark universe parallel to our luminous world. Dark matter, dark energy, and interstellar space make up much of the cosmos and may contain answers to yet unknown phenomena. Although we cannot see or directly measure dark matter, we can observe its effects. Dark matter is a fundamental element of the universe's matrix, while dark energy is its fuel. Other dark objects, such as brown dwarfs and black holes, suggest that a parallel cosmos exists, coexisting with ours and perhaps influencing visible structures. Despite technological advances, we are just beginning to scratch the surface of these cosmic mysteries. The brown dwarfs that shine in the infrared spectrum might be true bright suns in another dimension, essential for worlds that depend on this light, just as we depend on our sun. When we analyze these celestial bodies at the quantum level, we discover that quanta, particles of light and information, are the essential building blocks of reality. All matter, including that of brown dwarfs and dark stars, is made of light, albeit in forms that we cannot perceive with our eyes. This discovery aligns with string theory, which postulates the existence of dimensions beyond our 4. These dimensions might be around us, invisible but present. Subscribe to the channel to discover more fascinating mysteries of the universe.